What's going on, E9s? Welcome to our Thursday double. Today we're going to take a look at how to use formulas and how to substitute values into formulas. I'm sure you've done this before in year 8 when you had to do the measurement topic where you have area formulas, volume formulas, same thing, but here we've got some more abstract formulas. Okay, so let's take a look at the first example and let's see if we can make sense of it. What we have here is an equation, A equals T on 1 take away B. They tell us the following information. T is 5, B is 0.5. To evaluate this formula, what we have to do is we have to substitute these values into the equation. So therefore, what we do is we say Control Z. Why did it do that? So what we say is therefore A equals, well, we know T is 5. So this goes up top. This goes where the B is. And we can say this becomes 5 instead of having T at the top on 1 take away 0.5. And so what we have to do now is we have to say, well, therefore, if we simplify the bottom, so we know the top is 5, the bottom is actually going to be 0.5 because 1 take away 0.5 is 0.5. What we then do is in our calculator, we can input 5 divided by 0.5, and then we get our answer of 10. So therefore A equals 10. Okay, so once you figure out how to plug the numbers into the formula, you just work out the right side arithmetically. Okay, let's delete that one there. Cool. Let's move on. Hopefully that makes sense. If you have any questions, remember to email or comment down below. Here's a slightly more complex formula. We've got our equation here, and then we get the following information saying U equals 25, A equals 10, and T equals 4. So therefore, to find S, we have to replace U with 25. Okay, so U becomes 25. T becomes 4. But remember, it's not 254. When you have two prime numerals next to each other, there's a little secret times in between. So it's actually 25 times 4. We've got our plus half. So our plus half is here. And then the A, well, the A is 10. And remember, when you have two terms next to each other, or a number and a prime numeral next to each other, here we've got a fraction, same deal. There's a secret little times in between. So this is half times 10, and then the T squared, this, well, T we know is 4. We put the square on top, and because it's next to the A, we put a secret times in between. So therefore, this equals, we know 25 times 4 gets us 100. Or you could just input this in your whole calculator, up to you. There's no right or wrong way to do it. We know we have to do the addition last. We know this part, well, 10 times 4 squared. 4 squared, remember, is 16. So 10 times 16, what does that get us? That gets us 160. Okay, to save time, feel free to plug this into your calculator. Before we do the add, so the subtraction just keeps going because that's the last part we do after bid math. We know half times 160 is 80 because half of 160 is 80. Well then, 100 plus 80, that gets us 180. So there you have it. There's our answer. Alternatively, if you go 25 times 4 plus half times 10 times 4.5 in your calculator, you should get 182. So, or 180 as well, not 182, 180 as well. So feel free to do what's suitable for you. The next part is, once we know how to substitute values into formulas, they up the difficulty and they say for us to find the unknown value within the formula. So here we've got our area of a trapezium, A equals half times A plus B in brackets times the height. What they tell us now is the big A equals 24, so the area is 24. The little b is 3, and the h is 2. And our task is to find the value of A. So what do you notice? Whoop, that's unintentional. What do you notice? Where's A in the formula? If you answered with A being within the formula, and notice how in the previous examples, we were just finding the outside value. We're just finding the outside value, A and S, in examples A and B. Now we have to find the pro-numeral when it's within the heap of the formula. All right, so what we have to do is, let's write this out. So let's write it out bigger. So our equation is A equals half times A plus B times the height. All right, so we've got our multiplication sign so we don't forget. And we've just rewritten this part down here. We know A is 24. So A here is 24. We don't do anything with a half. We know little a we have to find, so we have no idea what it is. And we know little b is a positive 3. And we know the little h is a 2. So now that we've plugged everything in, what we have to do now is we have to get A by itself on the right side of the equation. So we can't eliminate the brackets here because A and 3 are not like terms. So we can't add them together. What we have to do is we therefore say, well, we can deal with the outside of the brackets. So we've got half and times 2. Well, we know if we multiply these two together, half times 2, and we leave this part separate. So we've just rearranged it. So we've had these two on the outside, we can deal with them. Well, we know half times 2, well, half of 2 is 1. So half times 2 means half of 2 is 1 times A plus 3. If we expanded this out, what we're actually left with is 1 times A, which gets us A. 1 times a positive 3 gets us positive 3. So we've basically eliminated these two terms, okay? So now that we've got a more, I guess, simpler equation, we can start dealing with the plus 3. How do we get rid of this positive 3? So therefore, to get rid of this positive 3, if you said we throw it to the other side and change it to a negative 3, you're correct. Therefore, we've got 24 take away 3 on the left side, and that gets us 21. And on the right side, we've got A by itself, and we figured out for this equation to equal 24, okay, on the left side. On the right side, the value of A needs to be 21, because 21 plus 3 gets us 24. Okay, half of 24 is 12, and then 12 times 2 gets us 24 again. So we know equation is correct once we plug this number back into our original formula. I'm hoping that process makes sense. This is really testing your knowledge on BidMaths and also linear equations. So it's very much problem solving. Again, if you have questions, shoot it through via email and we'll see if we can link up via Zoom and we can do some together one-on-one. The last part is transposing formulas. This is super abstract because we now no longer have any numbers involved or minimal numbers involved. All right. So what we have here is you're probably not going to get example B on the exams or on the test, or both for that matter. Let's do example A first. We have to make A the subject. So what that means is we have to get A by itself. So get A, oops, sorry, damn it. Get A by itself. So what this means is we've got a 2 to deal with and we've got a negative AC to deal with. Have a think about our acronym for linear equations. Let's see if you can apply that now. So this is our acronym of elimination in linear equations. Well, we no longer can get rid of the brackets because we're not actually dealing with any numbers here. So when we're dealing with the abstract, we don't have numbers in the brackets, so we can't actually deal with that anymore. We don't have any addition terms. We don't actually have any numerical subtraction terms because the takeaway C is in a brackets anyway, and it's not a number. We don't really have any division, but we do have a times 2. Okay, so the times 2, we can actually get rid of first. So times 2 is right there. What we say to ourselves is, well, what's the opposite of multiplying by 2? The opposite is to divide by 2. So if we were to chuck this on the other side, we would end up with B divided by 2 equals A take away C. And straight away, what we've done is we've eliminated the brackets because initially this was 2 times A, 2 times negative C. All right, we can get rid of the outside brackets, whatever term is outside. Here we've got a 2, and just chuck it to the other side and divide it by 2. What we notice now is we've got a negative C here. So the negative C is problematic because we got to get A by itself. And we have to think to ourselves, well, what is the opposite of taking away C? Doesn't change if it was take away 5, take away 10, take away any number, take away C, any letter. The opposite is always going to be addition. So take away, the opposite, if we chuck it to the other side, is addition. So we've got plus C on the right side. And so we've got A by itself, and this is our answer. So we can always rearrange it. The book will always put A on the left side, and we can say that's our final answer. Okay. Let's take a look at B. Okay, you might get this in the questions. I assume it's in the questions because it's here, but unlikely to be on the test or exam. What we got to do is we got to get little a by itself once again. So if we write our acronym, PASDMI, have we got any brackets? No. Have we got any addition terms? No. Have we got any subtraction terms on the A side? Yeah, we do. All right, so the subtraction term we're looking at here is the negative B. Okay, so what we have to do is we've got to get rid of that first. Negative, take away, same thing. So what's the opposite of a negative or take away? Well, if you guessed, or if you said positive or plus, you're correct. So we've literally just chucked this onto the other side. And we've changed the minus sign to a plus sign, negative to positive. What we then do is, well, a squared, like we've got rid of the subtraction, we don't have any division, we don't have any multiplication, but we do have an a squared here. So our a squared is what we call an index or an indice or a power. That's what the I stands for. How we get rid of this is, well, what's the opposite of a square? Can you have a think? How do we throw this to the other side? If you answered with the opposite of a square is a square root, you are correct. So to chuck this on the other side, we square root the entirety of the other side. Okay, so this is the opposite of a square. All right, so the square here becomes a square root. If it was a cube, it'll be a cube root. You'll have a little 3 if that was a 3 on the root symbol. All right, and then there's our answer. Our answer is square root c plus b. Does that mean anything? Nope. It's just a bunch of abstract equations which don't really mean anything, and it's just seeing if you can put together these linear equation rules and BidMath rules together to make whatever pronumeral they tell you as a subject. Here, it happens to be 8. All right, let's jump to our textbook. We're up to the last exercise. So what I want you guys to do is have a go at question 1, 2, 3, 4, and do every second question. All right, so 1, 2, 3, 4, every second question. Please, please, please email through any questions you have, and we'll make a Zoom one-on-one conference to solve it, because these aren't likely going to be resolved via email. Okay, that's all for the double. Let me know if you have any questions, and have a great Thursday.